In this video, I'm going to help you with the Algebra Review, specifically a 9.1, so that way you can complete the rest on your own. So if you're struggling, get out the 9.1 and go to the last page, and we'll work on each of these problems together. Okay, so these first two problems, this one and this one, are inequalities, and that means that there's not just one answer to make this equation true. There is an infinite number of answers that make it true. However, solving this is just like I would solve any equation to start off with. So your choice, you can either distribute the 2 in, or you can go ahead and divide by 2 right away. So I'm just going to divide both sides by 2. And I get 17.5. I'm going to subtract 3 from both sides. Negative 2x. 14.5, and then lastly, I'm going to divide by this negative 2. Now, whenever you're dividing by a negative, right, when I divide by a negative, I have to flip the sign. So this is now going to be x is greater than negative 7.25. Okay, and then we can graph our solution to show all the possible values that would make this equation true. So I want to go over to negative 0.25. It would be an open circle because we're not including the negative 7.25, and it's all the x's that are bigger than. So that would be all of these. So I'd shade that way. Okay, let's look what this means. That means that if I were to plug in any of these numbers except for negative 7.25 and all the ones that are less than, it would make the equation true. So I'm going to just check it really quick to see if that works. I think the easiest number to work with, since 0 is one of the solutions, I could choose any. I'm going to choose 0. So if I take 3 minus 2 times 0, 35. 2 times 0 is 0. 3 minus 0 is 3. 2 times 3 is 6. Yes, this is correct. 6 is less than 35, and that would work for any of these numbers. Now, if I hadn't switched this, you do not need to write this down, but I just want to show you, if I had not switched this, let's say I said, I think this is my solution, right? Then that would mean that all the numbers less than negative 7, so for instance, negative 10. So if I wanted to try that and see if it worked, I'd have 3 times 2, I'm going to put in negative 10, right? That would be one of the solutions over here if I hadn't flipped my sign, is less than 35. Okay, so I have 2 times 3, a negative times a negative is a positive 20. It's less than 35. Now I have 2 times 23 is less than 35, and 2 times 23 is, 46. You can see that this is not true, right? That's because this would be an incorrect answer if I did not flip my sign. So I'm going to erase all that so you just have the right stuff on there. But there you go. All right, so same here. Go ahead and give it a try. Pause and see if you can figure this one out. Okay, here's what I came up with. You could have started anywhere you wanted. I decided to get rid of this 5 first. So I subtracted 5 from both sides, and I got this, 3 plus 6x. Then I wanted to combine my like terms to the same side. So I subtracted 6x from either side, and I have negative 2x. That means that I'm dividing by a negative again. You could have solved it a different way. As long as you got the same answer, you're fine. But either way, the way I solved it, I ended up getting a negative here, which is fine. I just need to remember that when I divide, that I have to flip that sign there. All right, so when it's talking about all the x's that include negative 3 over 2 and that are less than negative 3 over 2. So that's the same thing as x is less than negative 1.5. So I'm going to go find negative 1.5, and I'm going to give it a filled in dot, and now it is all the values that's less than. So I would shade in this way. That means that if I were to plug this number back into here, it would make a true. I'm not going to check it again, but it would work out, right, where I make a true statement. Or if I plug any of these numbers into here, it would make a true statement. If I plugged in any of these numbers over here, it would not make a true statement. Okay, next thing here, graphing. The easiest, or usually the most known way to graph this would be to put into y equals mx plus b form, which is called slope-intercept. So we want to get this so that it actually looks like y equals mx plus b. Okay, there's other ways to graph, but we're just going to stick to one way. So I need to isolate the y, so I have to get it by itself. So I'm going to subtract 2x, subtract 2x. These cancel out, and I'm left with 3y equals, I usually put my x term first, so negative 2x minus 9, just because we see that our x term is first here, and I think that that usually works out best for our understanding. Okay, then we're going to divide by 3. They cancel out here, and I'm left with y equals, now be careful, you need to make sure that you divide both of these. Okay, we are wanting a fraction here, so we're just going to leave it as a fraction. That helps us count off our slope. And then negative 9 divided by 3 is a negative 3. So this is the y-intercept, which means that's where I am going to start graphing this line. Here's my y-axis. I need to go to negative 3 on my y-axis. That's the y-intercept. So 1, 2, 3 is right here. This is my slope. Okay, slope is always going to be your change in y over your change in x. That little triangle means change. Or you can think of it as the up, down, over the left, right. Okay, so that means that I need to go down negative 2. When you have a negative here, you could just decide, is it going to go on the 2 or the 3? You can't put it on both, but I'm just going to put it on the 2 here. Doesn't matter which one you put it on. So that means that I'm going to go down from this point, negative 2, and then plus 3 in the positive x direction is this way. So down 2 plus 3 gives me a point right there. Right, to show you that I could actually plot this slope as also 2 over negative 3, right? I could go up 2 and then back 3, and I can see that I'm still going to be falling on the line here. Up 2, back 3, up 2, back 3, and there I get lots of dots so that way I connect this and get my line. Okay, let's talk about what this means for a second, because that'll help us in the next one. What this line represents is a whole bunch of x and y, right? Every single point on this line, I didn't hit it very well, but this point, and this point, and this point, but also the points in between, right? All these points on the line. There's an infinite number of points because we could have decimals, we can have fractions, right? So all those points, if I were to plug in that x and y into this equation, any one of them, right? Each of these points is a coordinate pair and has an x and a y. If I were to plug those in, it would make the equation true. I could pick any one on there. Okay, that's a little bit different than what we're doing below. Okay, for this one, now we want all the x and y's, so all the points on the coordinate plane that would make this equation true. It starts off the same way, right? I want to get it into slope-intercept form, so I'm going to isolate the y. I'm going to start by subtracting 4x from both sides, and now I have negative 2y is less than or equal to negative 4x plus 10. I am going to divide by negative 2. That rule that you have to flip the sign holds true here as well. So I'm going to flip my sign, and now I have 2x minus 5. All right, so now I need to graph this line. So I'm going to go down to negative 5. 1, 2, 3, 4, 5. And then it looks like I don't have a fraction here, but I need a numerator and a denominator to graph this. So any whole numbers I can just put over 1. These are both positive, so I'm going to go up 2 and positive 1. Up 2 and positive 1. So up 2, positive 1. I like putting lots of points so that way I can connect them all. Okay, this problem is not done, but I want to show you something really quick. Do you see how this is a negative slope and this is a positive slope? Always check at the end when you've graphed your line that if it's negative, it's going downhill left to right. If it's not, then you just plotted something wrong here, right? You want to make sure these make sense with each other. Here, if this is positive, it should be going uphill left to right. If it is not, then you counted something off in the wrong direction here. Okay, that's just a way to double check. Okay, so up here, all these points, these infinite points on this line would make this equation true. Down here, It's looking for all the points that would make this inequality true. And what it turns out to be is more than what's just on this line. It's a whole bunch of points, and we show that by shading. Okay, so first let me show you that when it is n equals 2, it's all the points on this line, but in addition, there are other points as well. Let's say for a moment that it was not n equals 2, right? It was just greater than. In that case, I would want to shade my line like a dotted line. So I would want to change it. Okay, I just made my line dotted, and all that means is the points on here would not make the equation true, because the points on here would make it so that it is equal, right? And I did not include this equal. So let's go back. The problem that we're given here is equal to. So I'm going to fill this in. Okay, but there is a whole bunch of points that are not on the line that would also make this equation true. The way to figure that out is once you have this in slope-intercept form, just look at this part here. Okay, it says the y's that are greater than. I always think of it as like the y's that are greater than this line. So if this is our line here, and it's all the y's that are greater than, well then y's get bigger this way, and y's get smaller that way. So every time you're just thinking, do I shade above or below the line? In this case, because it's greater than, I'm going to shade above the line. You can shade all this in like this. Okay, that would be that problem finished. Okay, we are not going to do the factoring because you did not get very far into that last year, and we're not going to worry about that right now, but we should be able to do this. Okay, and a way to remember how to do this is the acronym FOIL. FOIL meaning front, outer, inner, and last. Okay, what that means is if I'm doing the front two terms, this is the front, and we're multiply them together. This, because there's parentheses around it, and this is the whole binomial is being multiplied by this whole binomial. So 2x times x, an x times an x is x squared, so 2x squared, do not forget your squared. Then we're going to do the outer, so it's on the outside of our two sets of parentheses. So I have 2x times 3x would be 6x. Then I have my inner, so that's the I. Negative 5 times x is negative 5x. And then finally, I would have L for last. So that's negative 5 times 3 gives me negative 15. Once you do this process, oftentimes, you are going to have this that you're going to combine because they're like terms. This would not combine because it has a squared on it. And this would not combine because it does not have an x. So we have 2x squared. 6x minus 5x is 1x, or I can just put x and then subtracting 15. Okay, I hope that helps you understand these first problems. That will set you up to be able to do all the other reviews. And then you'll be taking, as part of your final mastery check, an algebra section that includes problems like this.